Hello everyone. Today's topic is limitations of rectilinear kinematics. In your class 9 and 10 or 11 and 12, you might have studied this chapter of mechanics. Means it is a chapter from the subject of physics where you have studied rectilinear kinematics. Means motion of particles or any object along a straight line. Okay, and you know that in the chapter of kinematics, okay, in that branch of mechanics, kinematics, only motions are analyzed but not the forces causing the motion. That part is called kinematics, and the part where motions as well as the forces causing the motion are analyzed simultaneously, that part of mechanics is called kinetics. Here we are talking about only kinematics, means only motions. Motions of what? Motions of objects or any particles along straight lines, not along curved paths. So you know that three equations you frequently use to solve the given problems from the field of kinematics, rectilinear kinematics. The equations are these: v is equal to u plus at, x is equal to ut plus half at square, and v square is equal to u square plus 2ax. Here v is the final velocity, u is the initial velocity, a is the acceleration, t is the time, and x is the displacement. And you know the meaning of displacement. Okay, displacement is measured along straight line from initial point to the final point, not along curved path. Okay, if you measure the distance along the curved path, then that is only distance, not the displacement. Say for example, a particle moves from this point A. Say this point is denoted by A and this point is denoted by B, following this path. A particle moves from this point to this point following this path. Then what is the displacement of the particle? If you measure the length along this path, then that is not the displacement. Displacement will be if you join the point A and point B by a straight line. Say, so this is the straight line, then this distance along this straight line is the displacement. And here in this equation, x represents displacement. Displacement is this one, not this one. Along the curved path, the distance is more than along the straight path. This is known to you. Okay, so what is the limitation? Limitations of these equations. I should better write here. I should have better written here. Limitations of equations of rectilinear kinematics. I have omitted that part, the equations. Okay, so these equations cannot be used in this case where the motion is along a curved path. Okay, you cannot measure this displacement by using this equation. Okay, so that is the problem. Here A represents acceleration and this is constant acceleration. This is not changing with time. If acceleration is given as a variable, say acceleration changes with change in time, acceleration changes with change in displacement, in that case these equations cannot be applied. So this is the limitation. Whenever you are using these equations, means motion must be along a straight line. If motion is not along a straight line, please don't use these three equations. Okay, if motion of the particle or the given object is not along a straight line, in that case you must not use all these three equations. Okay, these are not valid. So that is number one, point number one. Motion must be along straight line, not along curved line or curved path. Next is about acceleration. Acceleration must be a constant quantity. It should not change. If acceleration is not constant, then you cannot use these three equations. Then that is another limitation. of these equations, acceleration must be acceleration or retardation. Okay, that must be a constant quantity. What is the third point? Third point is, if the velocities involved in the calculation are comparable to the velocity of light. Okay, you know the velocity of light is 3 lakh kilometer per second, or 3 into 10 to the power 8 meter per second. In that case, if the velocities involved in your calculations are comparable to that, means near to that value, okay, in those cases you cannot use these equations. That is the limitation. Okay, say the velocity of the particle is 1 lakh kilometer per second, or say it is 50,000 kilometer per second. So these velocities are comparable to the velocity of light. Somewhere it is 5% of the velocity of light, somewhere it is 1% of the velocity of light. In those cases, you cannot use these equations. Yes, you can use. If you use, then the experimental result or the practical result and the theoretical result will not match with each other. Okay. Whenever you are going to use any equations, so you must know the limitations of those equations. Okay. Without knowing the limitations, if you use the equations, then there is a chance that you are committing some mistake. And in that case, your theoretical result or the result of calculation and the experimental result won't match. Okay. So these are the three limitations of rectilinear kinematics. Means equations of the rectilinear kinematics. Last one was what? If the velocities are very low, in that case only. Means if the velocities are not comparable to the velocity of light, in that case only you can use these equations. Okay. So this lecture was about the limitations of the equations of rectilinear kinematics. Okay. So this is the end of this lecture. If you have any queries, please write me in the comment box. And if you like my videos, please like and subscribe to my channel. Okay. This is a new channel. I am going to upload here in this channel different topics from physics. Mostly physics will be there. Again, along with physics, chemistry, mathematics, and other subjects of sciences will be there. Okay. Okay. So this is the end of this lecture. Thank you. Thank you for watching this video.